Hello friends, this video on chemical bonding part 19 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 18. Let's now discuss the theories based on quantum mechanics. We have seen the other approach we had was the Lewis theory and the Vesper theory. It helped in writing the structure of the molecules, but it failed to explain the formation of chemical bond, why the bond forms. It doesn't explain that. It doesn't give any reason why H2 and F2 have different bond enthalpies. It also doesn't talk much about the shape of the polyatomic molecules. Vesper theory, which we have, is criticized actually because it is not quantitative. Just based on observation they have found it, but it's not quantitative. There is no crude reason why it should be of the particular shape. Just based on observation they have given this theory, but it's not quantitative. It's not structurally accurate. And to overcome these limitations from these experimental ways, they came out with the theories based on quantum principles. And these theories were valence band theory and the molecular orbital theory. Valence bond theory it generally gives the shape, and the molecular orbital theory is also for the shape but generally gives the properties of molecule, whether it is paramagnetic or what is the bond length, is stable or not. So it's more about the chemical properties of the molecule is given by the molecular orbital theory, and the shape is mostly given by the valence bond theory. So we learn valence bond theory now. So this theory focuses on how atomic orbitals combine to form chemical bonds in the molecule. And it is based on the energy reduction. The whole quantum theory is based on the energy reduction. As I told, energy is like stress. Everybody want to reduce their stress. Every atoms want to reduce the energy. And this theory is all based on energy reduction. And according to this theory, the covalent bond is formed between the two atoms by the overlap of half-filled valence atomic orbitals of each atom having unpaired electron. Please note, I'll repeat the statement, it's a very critical line here. So it says the covalent bond is formed between two atoms by overlap of half-filled valence atomic orbitals of each atoms containing one unpaired electrons. I'll explain more on this, I think, in the next few slides if you don't understand this. So it says, for example, I have one s orbital. Let's understand the concepts of hydrogen in the hydrogen atom. Let's understand the valence bond concept. We'll take two hydrogen atoms, and if we assume these hydrogen atoms are coming towards each other, so in that case, if you see now, four force appears. Right, these are the attractive force that appears. So if you see, this is my nucleus 1, this is nucleus 2, this is my electron 1, and this is my electron 2. So there is a attraction between nucleus 1, electron 2, right? There is again attraction between nucleus 2 and electron 1, right? There is already attraction between this, the dark blue line is already existing attraction between nucleus 2 and electron 2 and nucleus 1 and electron 1, plus more attraction came. The blue one is the attraction and the green one is the repulsion actually. The new attraction developed, so I'll say my old attraction was nucleus 1, electron 1, nucleus 2, electron 2. My new attraction is nucleus 1, electron 2 and nucleus 2, electron 1. My new repulsion also came, that is nucleus 1, nucleus 2, electron 1, electron 2. So these new forces came into play. The one with the dotted is the new forces, the blue one is the attraction force and the green one is the repulsion force, right? But overall it has been seen that the way it comes to each other, if it is an infinite distance, there is no energy actually, it's zero energy. If it comes to each other,
the energy decreases and comes to very minimal level, and then it goes up again. Why? Because if you try to bring them closer more, it will repel more, right? There is one place where it achieves a stable configuration, and that is at this stage where both are almost combined, and this is found experimentally for hydrogen atom. This is for hydrogen. So what they have done is they have taken two hydrogen atoms, they separated. There is no energy between them, right? There is no energy because it's in a separated infinite distance. When they come together, the energy goes down. It went to a minimum level of minus 435.8 kilojoule per mole, and again it went up. Because further this, if you try to squeeze these two atoms, there will be more repulsion by these two nucleus and these two electrons. So it will become unstable. But at this position, it is pretty stable. So this is a stable state, and this is derived experimentally. Experimentally, they found that, so if you take hydrogen atoms, at this state, it is more stable because the energy is lower here. Right? When it is at distance apart, there is no energy, it is all zero energy. But when it comes near, it loses energy, it becomes very stable, and again it becomes unstable. So at this point, it becomes very stable, and this is the crux for the valence bond theory. Please understand this. This is the main concept behind valence bond theory. Experimentally, they have found for hydrogen atom, as a distance between the atoms is decreasing, the energy also decreases, it becomes more stable, and if you further decrease the energy, the distance, if you further decrease the distance, the energy increase and the atoms becomes unstable. So as I have told, experimentally we have found this, that the new force which is there, the magnitude of new force that comes is more than the new repulsive force. The new attractive force is more stronger than the new repulsive force, and that's why when they approach each other, the energy of the system decreases. Ultimately, I show you the stage where the net force of attraction balances the repulsion force, and this attains a minimum energy. And at this stage, the distance between two hydrogen atoms is 74 picometer, and that's why the bond length of hydrogen is 72 picometer. And since the energy is released in this, the H2 molecule is more stable than in isolated hydrogen atom. So my H2 hydrogen molecules becomes two atoms becomes molecule, and in this energy is released, so this is more stable, and this energy release is 435.8 for 1 mole of hydrogen atoms, and so this is called bond enthalpy. Correct? And conversely, if you have a hydrogen molecule, if you want to convert it into hydrogen atoms, you need this 435.8 kilojoule of energy to convert 1 mole of hydrogen molecule to hydrogen atom. See, this is the picture we had. The distance, when the distance became 74 picometer between the nuclei of two hydrogen, right? This is 74 picometer. This was stable, and it released 435.8 kilojoule of energy for 1 mole of hydrogen atom. Correct. So now let's discuss the orbital overlap concept. So what we have seen till now is experimented things, right? Experimentally, they have put two hydrogen atoms near to each other, and then they found some energy was released, and H2 was molecules formed which was stable. Now this was an experiment phenomena. To explain this phenomena, orbital overlap concept came. This is a theory actually, right? This is theory only. What we saw earlier was experiment. This is a theory which came to explain the experiment, right? So it says that when we have seen the last experiment where the hydrogen molecule was formed, there is a minimum energy state at 74 picometer distance where it says as hydrogen atoms undergo partial interpenetration. That means the orbitals overlapped for the two hydrogen atoms. For example, if you see here SS orbital, they overlap to form SS overlapping. Where if you see there is a place where there is overlap. If there is a S orbital overlap with P orbital, then also we have some overlapping. So it says that overlapping is nothing but interpenetration of orbitals. Partial interpenetration of orbitals or partial merging of orbitals. Right? This is called overlapping of atom orbital. And they are saying that this is the result of electron pairing. So there is one electron here, and they pair up. Right? And the extent of overlap decides the strength of the covalent bond. If the overlap is more, strength is more. Overlap is less, strength is less. Right? So according to the overlap concept, let's understand once again. The formation of covalent bond is the result of pairing of electrons that are present in the valence shell of two different atoms, and they have opposite spins. So there is one spin here, one spin here. I'm talking about the valence shell, and they overlap and they get something like this. Correct?
Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.